In the 1970s, Apollo astronauts spotted something weird on the moon. Just before sunrise, they saw a strange glow on the horizon. Moments later, radial bands of light streaked across the sky, just like when sunlight spears through clouds on Earth. Now, that might not sound so weird because we see stuff like that all the time. But that's because Earth has an atmosphere which scatters light. The moon doesn't. The best explanation anyone could come up with was that the light was being scattered by dust, but no one knew why there would be dust floating high above the surface of the moon. Decades later, scientists figured out that there almost certainly is dust floating above the surface, and the same physics that keeps it afloat is likely reshaping airless worlds all over the solar system. Even though it was hard at first to understand why dust was floating above the moon's surface, the clues were all over. In the mid-60s, a few years before the Apollo astronauts saw this glow with their own eyes, the Surveyor landers captured it in pictures just before lunar dawn. These images showed a glow about 1 meter above the ground. Later, during the Apollo 15 and 17 missions, astronauts saw the glow again, but this time it was at a much higher altitude. So there was dust close to the ground and dust high above it. But then there was a twist. Sometimes there was no dust at all. In photos from the Apollo 16 mission in 1972, astronauts didn't see anything. No hint of dust above the surface. So scientists were stumped. What could possibly be tossing dust above the surface, high above the surface, but only sometimes? They knew that tiny collisions from micrometeorites can kick up dust. These impacts happen all the time, and they create the dust in the first place. But without any atmosphere to hold it up or blow it around, the moon's gravity should just pull the dust straight back down. So something else had to be involved. Scientists now think that something is electrostatic forces. See, without any real atmosphere to act as a shield, the surface of the moon gets bombarded with a combination of UV radiation from the sun and charged particles from solar wind. On the day side, the effect of the sun's UV rays dominates, since that's the side directly facing the sun. The radiation is powerful enough to knock electrons off the dust particles, giving the moon's surface an overall positive charge. Since like charges repel, the dust particles move away from each other, and the easiest way for them to escape is up. So you get particles levitating above the ground. Meanwhile, electrons and ions from the solar wind build up on the night side, giving it an overall negative charge. The result is an electric gradient and streams of charged floating dust particles redistributing themselves across the surface. That's the theory, at least. There are no direct measurements of electric charge from the moon, so all we can do is make predictions based on Earth-side experiments and models. But based on these studies, scientists think the consequences of electrostatic forces could be really dramatic. Research suggests that fountains of tiny dust particles could be projected up to hundreds of meters above the surface. And all around the moon, dust is likely moving around to minimize the electric gradient, which is a lot of action for a barren rock with no air. And there's a good chance that this same type of electrostatic transport can explain some other strange features we see around the solar system, especially on other worlds without air. For instance, back in 2000, the Near-Shoemaker probe took close-up images of the asteroid Eros and spotted what astronomers called dust ponds, basically isolated patches of fine dust on the asteroid's surface, often inside craters. On a planet with an atmosphere, it's not hard to imagine the wind whipping up clouds of dust and dropping them where it's calmer. Without winds, though, these patches of dust are harder to explain. But 14 years later, the ESA's Rosetta lander sent back images of the same feature on a comet. Scientists think that electrostatic forces may be at work here, too. Just like on the moon, where day and night have opposite charges, UV radiation could charge the dust in sunny spots. That dust would then pick itself up, move across the surface, and plop down in shaded, uncharged places where the sun doesn't shine. That's right. You basically get electric winds on worlds with no air, which is seriously weird. And it might be happening in more places than we think. like Saturn's icy moon Atlas, which has a strangely smooth surface. The tiny moon has a bulging equator, which it probably got from sweeping up debris from the giant planet's rings. But that bulge doesn't look like a pile of rubble. Instead, it's super smooth. So it may be that small, charged particles of dust are drifting across the surface, making it look more like an untouched snowdrift. For now, this is still based on observations, models, and simulations. But future lunar missions will be able to put these hypotheses to the test. And if they're correct, they have a lot to tell us about the way tiny, charged particles reshape entire worlds. And they may also force us to plan for dust when we think about future exploration on the moon. It seems like even there, we can't get away from doing the dusting. Thanks for watching SciShow Space. And if you liked this episode, it's not the only weird thing happening above the surface of the moon. You can check out this video next to learn about how the moon got its tail.